Let f be a polynomial function with values of f prime of x as selected values of x given in the table below. Which of the following must be true for -3 to 6 for our x values? So we have -3 to 6. We have a bunch of coordinates given to us. All right, now this is f prime of x. Okay, and we want to talk about facts of f prime of x. So what we know is the derivative gives us slope. All right, negative derivative is going to be decreasing function. Positive derivative is going to be an increasing function. So let's kind of go through all of this stuff and see what we have here. All right, now the first one asks if the graph of f is concave up. Now, if you might remember from AP Pre-Calculus, concavity has to do with the increase or decrease of its rate of change. I'm going from 4 to 0 to 2 to 6 to 3. Something is going to be concave up if the rate of change is increasing, and my rate of change is not increasing. In fact, I start out by decreasing. So since my rate of change is not increasing, this guy is not concave up. The graph of f has at least 2 points of inflection. All right, well, looking at what I have, it looks like f prime changes direction twice. Right? Because I go from 4 to 0 to 2, so that's a change of direction. And then from 2 to 6 to 3, there's another change of direction. So since it changes direction twice, we can assume that the graph has 2 points of inflection. Now let's rule out the others. F is always increasing. That's false because f prime of 1 is 0. Which means if it's always increasing, if f prime of 1 is 0, this means we have a 0 slope right there, which means not always increasing, so C won't work. F has no critical points. Well, that's not true because there's one right there. And so you're not right. F has at least 2 relative extrema. No, because it's always increasing except for at one spot. So we can't determine if there's more than one relative extrema. So B's got to be it. So this is a calculator section that didn't require a calculator. It just kind of required a little bit of knowledge about the derivative and how we can use that derivative to our advantage.